Hey guys, so from what I remember, you guys are going to be working on polygons and there's the interior angle sum. That means the total degrees inside of the polygon. So we're going to do this just like we do the composition entries. I highly suggest you write them down. If we end up going back to school, I might let you use them on the final. Might. Okay? So anyway, you guys already know certain polygons have special names. We've already been working with triangles. We've already been working with quadrilaterals. Okay, so triangle has 3 sides and it equals 180 degrees. You should know it like that fast now. Okay, a quadrilateral has 4 sides and it's 360. Again, you guys know it like that fast already. Now, there's a whole bunch that have special names. There's only one that doesn't have a special name. Okay, that's 4. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is normally referred to as a heptagon, like the little pop in it, kind of. Heptagon. 8 sides is an octagon. 9 sides is a nonagon. Not nonagon. No. Not nineagon either. 10 sides is a decagon, like decade. Okay, 11 is the one that doesn't have a special name, and 12 is the last one with a special name. So 12 is a dodecagon. Now we want to fill in the rest of these numbers here. There's a special formula that you can use to do that. Well, in a triangle, there's only 180. We know that. In a quadrilateral, because you can make 2 triangles inside of it, here, let me show you, and I'll erase this later, don't worry. Here's a quadrilateral. Because there's 2 triangles inside, it's 360. Well, what about a pentagon? We have a pentagon that looks like this. How many triangles can I draw? Going from one vertex to another. Don't go from the center and say, oh, I can draw 5 triangles inside. You have to start from one vertex and go to another vertex. Can't go this way because there's a line already there. We could go this way. We could go this way. So how many triangles do we have? We have 3. 180, 180, 180 total. So your grand total, if you have to cut them up and put them back together, just like when you guys were doing those composite area figures, it would be 540. Okay, but there's a formula. Instead of having to draw it out and draw all the triangles and take forever, there's a shortcut formula. The formula is n minus 2 times 180. You take the number of sides that the shape has, subtract 2, and then just multiply it by 180. So this is 540. 5 minus 2 is 3 times 180, 540. Okay, 6 is, what is 6? So we got 6 minus 2, 4 times 180, 720. Okay, and it just keeps going on and on and on and on and on. Okay, you guys can go ahead and make sure you fill in the rest of them. It will help you later as like, oh, I have a chart. Oh, my assignment's asking this. I could just look at my chart. So make sure you fill that out. Okay, now remember, this is total degrees. Okay, so now I'm going to show you something else about interior angles. Okay, like I said before, the formula is n minus 2 times 180. N minus 2 times 180. You're going to use that formula for like a lot of things. So let's try a dodecagon. Okay, dodecagon. Dodecagon has how many sides? We look at the chart, it tells us we have 12 sides. Okay, so what you would do is you would fill in the formula for dodecagon. Okay, it's 12 minus 2 times 180. 12 minus 2 is 10 times 180, 1800. Okay, that's the total. The total in a dodecagon, all the angles added up together have to equal 1800 no matter what. Okay, that's the total. But what if we wanted to find how many degrees each angle was? They're going to shoot some vocabulary words at you, like a regular dodecagon. Regular usually means normal, like, I don't know, regular school schedule, which we haven't had, okay? The normal school schedule. But when you're talking about shapes, regular means all the sides are congruent and all the angles are congruent, okay? So if we have a regular dodecagon, all 12 sides have to be equal and all 12 angles have to be equal. So if you wanted to find out, you have your total. What if I now wanted to find out how many degrees is each? I know they have to be the same. So what I'm going to do is I'm going to take your total and you're going to divide it by 12. Okay? 12 divided by 1800 is 150. Sorry, I had to do that by hand. I don't have my calculator with me. It's at my classroom. Okay, so each would be 150 degrees each. But remember, that's for a regular dodecagon. Okay? If it was irregular, that means the sides don't match, the angles don't match, there is no formula you can follow. So the formula we followed to do this, instead of doing all that, there's actually a formula. If you can remember it, it would be cool. Okay, it's n minus 2 times 180. But then what did we divide by? If we did the n minus 2, that became 10. A lot of people, the fastest, I'm sorry, not the fastest, the most common mistake that I've seen every time we've done this, people see the 12 minus 2, they say 10. So they want to divide by 10. No, you're dividing by the total number of sides or angles, it's going to match, of the polygon. So it's going to be n minus 2 divided by n. That will get you your each. Each for a regular this is a dodecagon, so regular polygons only. Okay, so I think this is what you guys are working on today. If it's anything other than this, or this doesn't help, or if you're stuck, please do a screenshot, send it to me. I'll respond as fast as possible, especially if it's on Remind. If you guys keep trying to send me messages on Schoology, I'll answer them. Of course I'll answer them, but it does take a little bit longer because Remind goes straight to my phone. The Schoology messages don't, and there's nothing I can really do about that. Okay, so keep trying on your work. If you get frustrated, reach out to me. I'm here for you. Okay, miss you guys. Talk to you later. Bye.